There's a force out there so common, so much a part of our everyday lives, that we just completely forget how powerful it is. It's not some crazy earthquake or a giant volcano. Nope, it's the very thing that sculpted the ground right under our feet, that shaped the air we breathe, and painted the entire face of our planet. We're talking about water, and today we're going to dive into how this simple little molecule became Earth's great architect.
But first, let me ask you a quick question. Think about the water in your glass right now. Is it even possible that a dinosaur drank that exact same water millions of years ago? I mean, it sounds kind of nuts, right?
Well, the answer isn't just yes, it's almost certainly yes. And that's because every single drop of water on this planet is part of this incredible, ancient recycling system, a journey it's been on for billions of years.
And if you want to see this power in action, look no further than the Grand Canyon. It's just one of the most mind-blowing testaments on Earth to what a simple little river can do if you give it enough time. We're talking millions and millions of years, just patiently grinding away at solid rock. That is water's surprising superpower.
But hold on, where does all that incredible canyon-carving power even come from? Well, to understand that, we have to look up about 93 million miles away, actually, because this whole system, it's powered by the ultimate engine for our planet, the Sun.
Probably the best way to picture this is to think of all the water on Earth as one gigantic, rechargeable battery. It is absolutely brilliant at soaking up the sun's energy, holding onto it, and then moving it all around the globe. And this one function, just absorbing and moving heat, is the engine behind pretty much everything that happens with our weather and our climate.
So here's the breakdown of how that energy delivery system works. When ice melts or water evaporates, it soaks up a huge amount of heat from everything around it. But that energy, it doesn't just vanish. It gets stored inside the water vapor as something called latent heat. It's like hidden energy, essentially. Then, as that vapor travels through the atmosphere, it's carrying that stored energy with it, and it can release it somewhere totally different when it finally condenses back into rain or snow.
Okay, so now that our water is all supercharged with solar energy, it's ready to get to work as our planet's architect. And it has three main tools in its toolkit. It's a sculptor, it's a chemist, and it's a global regulator. First up, its job as a physical sculptor. And it has two very different ways of doing this. As a liquid, it's like super fast liquid sandpaper, cutting those classic, sharp, V-shaped canyons we all know. But when it's solid ice in a glacier, it becomes this slow, unbelievably powerful grinder that carves out these massive, totally distinct U-shaped valleys. But here's the thing. Erosion is only half the story. When that fast-moving water finally slows down, it has to drop all that sediment it was carrying. So this means water is both a destroyer and a creator. It carves away land in one place and then builds up new, incredibly fertile land, like river deltas, in another. It's a whole cycle.
Okay, so that's the brute force method, but that's only part of the picture. Water also has this secret life, a more subtle, almost invisible job as a master chemist, transforming our world from the inside out.
You see, because water is such a great solvent, it can chemically reshape our world. Over thousands of years, slightly acidic groundwater can literally dissolve solid limestone, hollowing out these spectacular underground cave systems. It also seeped deep into the earth, filling up these vast underground reservoirs called aquifers. And when it gets superheated, way down deep, well, it can do something truly remarkable. It's a process called alteration. Basically, the superhot water dissolves minerals in one place, carries them along, and then drops them off somewhere else. In doing that, it fundamentally transforms one kind of rock into a totally different one. This is water literally remaking the planet's geology from the inside. It's incredible.
So water carves canyons and dissolves rock, but its third and biggest job happens on a truly global scale. And to get it, you just need one number: 70%. That's how much of our planet is covered by the ocean.
And what's amazing about all that ocean water is that it can soak up a mind-boggling amount of solar energy without its own temperature really changing that much. It acts as the planet's ultimate heat sink, our global thermostat, which stabilizes our entire climate and keeps temperatures from swinging into wild extremes.
So what does the ocean do with all that heat? It doesn't just sit there, it moves it. There's this incredible system of currents, like a global conveyor belt, that carries warm water from the tropics up towards the poles and then sends cold water back down. A current like the Gulf Stream, for example, is the whole reason London feels the way it does and not like northern Canada. This system is truly the engine of our entire global climate.
So we have this incredible system, sculptor, chemist, and regulator, all built over billions of years. But the whole thing rests on a really delicate balance.
And, well, that's where we have to talk about the human factor, because we're starting to disrupt this ancient system.
Just think about something as simple as pavement. In a natural forest or field, rain soaks right into the ground, slowly refilling those vital underground aquifers that we rely on for drinking water. But when we cover that same land with roads and parking lots, we basically create a waterproof seal. Now that water can't soak down. It's forced to run off sideways, which overwhelms our drainage systems and causes both flooding and erosion.
And there are other consequences too. When we pump way too much water out of those underground aquifers, we're removing the very thing that was physically supporting the rock and soil above it. The ground itself can actually start to sink. That's a process called subsidence. We are literally changing the planet's fundamental architecture.
And all of this, it leads us to a final and honestly a really critical question. We've come to understand that water is the master architect of our planet. So what happens when we start messing with the architect's tools?
So look, if water is the master architect, the force that shapes everything we know, what happens when our activities start to change the tools? When we start altering the water's temperature, its chemistry, its entire cycle?
It really forces us to ask ourselves, what kind of world are we now building for the future?